Hello friends, welcome to Data Science Lovers. In our last video, we learned about the empty function. In this video, we will learn about the I function in numpy library. We will start with the basic definition of the I function. Then we will see the syntax. We will create a simple I array. Then we will create the I array with main diagonal, the upper diagonal and the lower diagonal. And we will change the data type to integer. Then we will create I array with different number of rows and different number of columns, 4 by 5 and 5 by 4. And then we will see some additional examples of I array. Let's start. The I function returns a 2D array with 1 on the diagonal side of this array and 0 elsewhere. The syntax is simple. First of all, we have to use numpy library, which is denoted by np here, dot I function. In this I function, the shape of the array is mandatory, while these two parameters k and dtype are optionals. K represents the index of the diagonal and dtype represents the data type of the values. Kindly note these 3 points, which will be clear by doing some examples. Here, if only number of rows is passed, then the number of columns of the array will automatically become equal to the number of rows. Okay. K is the index of the diagonal and by default k equal to 0 means we will represent the main diagonal, and when k is positive it will represent the upper diagonal, and when k is negative it will represent the lower diagonal. And the third point is the default data type for this array is float. First of all, we will import the numpy library, and the syntax is import numpy as np. We will run this and the library has been successfully imported in this Jupyter notebook. Then we will create an array of shape 4 by 4, means we need 4 rows and 4 columns, for example. So we have to use the same syntax, np dot I function, and inside this I function the shape parameter is mandatory, so we have to pass the shape, and I am passing only one value here, suppose 4. We will save this in a variable name a. Okay, when I print a, then you can see an array of shape 4 by 4 is created and 1 is present on the diagonal of this array and 0 is present on other places. Okay, so here if you notice the first point, if only number of rows is passed, here I passed only 4, then number of columns will become equal to number of rows. I have passed only number of rows 4, then the number of column has also become 4. So this is the property of this I function. And also notice that it is a 2D array which is represented by these two square brackets in the starting, also at the end of this array. So that's how we can create a simple I array with same number of rows and same number of columns. Now we will use our second parameter, which is k, which represent the index of the diagonal. Again, np.I function, our shape of the array 4. This time if I write k equal to 0, k equal to 0 represents the main diagonal. What is this main diagonal? We will save this in a variable a, and when I print a, then the output of this array is similar to our previous array output. Why? Because the value of k is 0 by default, as we notice here. Okay, and when k is 0 means it will represent our main diagonal. Our main diagonal is that will start from index 0 of the array and will be in the middle of the array. Now in any case, if we want to represent the upper diagonal of this array, then we can give a positive value to k. np.I, our shape 4. This time I will pass k equal to 1, which is a positive value, and we will save this in a variable b. When I print b, you can see that the position of the diagonal has changed. Now it is starting from our first index, this one 1 1 1. So This is how we can create an I array with upper diagonal. Similarly, we can create the I array with lower diagonal, and the syntax will be np.I function, our shape, and this time we have to pass k as a negative value. I will pass k equal to -1. We will save this in a variable c, and when I print c, then you can see that the diagonal is started from this place 1 1 1. So this is the difference between the main diagonal, where the 1 will be in the middle of the array, and this array is with upper diagonal, and this array C is with lower diagonal. We can also change the data type of the values. By default, the data type is in float format. We can change it to integer also. So np.I function, our shape, and I am not using the k parameter now. I am using data type equal to int. Int is a short form for integer. We will save this in a variable named d, and when I print d, you can see all the values now are in integer format, and one is present at the main diagonal of this array. And now we can change the shape of the array. We can have different number of rows and different number of columns as well. np.I, first of all we have to pass number of rows. Suppose I pass 4 and then I pass 5. So 4 will become my number of rows and 5 will become my number of columns. We will save this in a variable e, and when I print e, you can see this array is 2D and it is containing 4 rows, 1 2 3 4 and 5 columns. And here, as the number of rows and number of columns are different, that's why the 1 is present in all rows but not in all columns. The last column, which is extra, doesn't contain the 1 value. It is containing only 0. If we create an array of shape 5 by 4, means I need 5 rows and 4 columns. And we will save this in variable f. When I print f, then you can see 1 is present in all columns but not present in all rows. What does it mean? What is the difference here? If the number of rows is less than the number of columns, then 1 will be present in all rows, and if the number of columns is less than the number of rows, then 1 will be present in all columns. And the condition here in both cases, that k must be equal to 0. K equal to 0 for both the conditions. Now we will see some additional examples of the I array using I function. First one is np.I. If I pass only one value, which is 1, then what will be the output? You can try in your notebook also. When I run this, it will represent only one value in float format, and this is a 2D array. Next is np.I. When I pass 12, what will be the output? Then it will create an array of 12 by 12, and the main diagonal will contain the value 1, and all values are in float format. Next, we can use an example np.I 6 number of rows, 9 number of columns, and here I am using the parameter k, and I am passing k equal to 3. It is a positive number. Also we will use the second parameter, or you can say third parameter, dtype, and dtype equal to integer. When I run this, then you can see all the values are in integer format, and there are 6 rows and 9 columns, but the diagonal or the value of 1 is starting from this position, or you can say the third index. Okay, this is our 0th index, the first index, and second index, and the third index, because we have passed k equal to 3. And as I told you in above examples, then whatever the less number, either number of rows or number of columns, 1 will be present accordingly. The number of rows is less here, so 1 is present 6 times only here in all rows but not present in all columns. these three columns doesn't contain the value of 1, all are 0. Next example, we can use np.I and 5, the shape, and d type. We can use the data type as string also. We will save this in a variable name small a, and when I print a, then it will show like this. All values are in quote now, which represent the string, but 0 is not shown here, only 1 is shown as string. Okay, and we can also check the dimension of any array using ndim function, which I have told you in my last videos. Ndim, and here we have to pass our array. Array is stored in A. When we run this, it is showing 2, means our array A is a two-dimensional array represented by these two square brackets. So friends, that's all for this video.